All right, I tend to talk like really loud, so
I got it.
You gotcha. Cool, awesome. So thanks everybody for sticking around. My name is Souza. I work for a company called Pluralsight, used to be Code School here in town. Got acquired a couple years ago, and I'm going to start off with the resources that I used to learn Elixir, the programming language. So this talk is not going to be necessarily about learning the language. I'm not going to focus on syntax, but rather I will focus on how to think functionally. So this was the first language that I actually got to write on a day-to-day basis that was a functional language. And before Elixir, I had tried tutorials with languages like Lisp, like Scheme, or different paradigms like Prolog, but I never got to actually use those languages for real-world projects until I learned Elixir. And these were some of the resources that I recommend for those of you that want to learn the actual language. So pluralsight.com, the company that I work for, we have a handful of courses on Elixir, and PragProg has some really cool books about it, and I want to point out that one especially, Learn Functional Programming with Elixir. I learned a couple of really cool tricks and things that happen behind the scene. Some of them I'll mention it on today's talk through that book. All right, cool. So, my personal history with programming languages, it started. I went to school for computer science, and in school we were exposed to our first programming languages, which happened to be object-oriented. So a lot of you might relate to that. At the time, you know, Java was the thing. PHP was kind of like the language for the web, and it kind of uses the object-oriented paradigm. So I kind of used those languages to learn how to program, and that naturally made me think of programming in terms of objects, right? So that paradigm was kind of, you know, the way that I learned how to think in terms of programming. So in order to learn how to program in a different paradigm, in a functional paradigm, I had to unlearn a bunch of things and look at code in a completely different way. So I'm going to talk about some of those things here tonight. So a little quick primer into Elixir. It's a programming language that basically allows you to program for the Erlang virtual machine. So Erlang has been around for over 3 decades. It was built inside of Ericsson, focused on the telecommunications industry in the market, right? There's a really cool video up on YouTube with the history of Erlang. It's like a 10-minute, almost like an infomercial, like a commercial, try to like sell the goal of the language back in the day. And this was in the late 70s, early 80s, and back then, we obviously didn't have any of the technologies that we have today. Internet wasn't widespread. We didn't have YouTube, Twitch, any of those things. And we basically had 2 things. So I was born in the mid-'80s, so I kind of like remember some of those things. And back in the 80s, like 2 things were really big. Bad haircuts, and also telephones, right? And that was the goal of Erlang, was to program to make it a little bit easier and more accessible for programmers to write systems for highly advanced telecommunication systems, right? And in the actual movie, the Erlang movie, they show telephone calls as the examples of where Erlang shines. So you watch the movie, you see person A making a phone call to person B, and then person C joining that call, and then person A dropping the call, and the person B and C still being able to communicate. So kind of like the group chat that today can be quite easily translated into the internet, right, into the network of computers. So it's not necessarily people talking over the phone, but we're still transmitting data over the wire. And it just so happens that a lot of the issues that people used to run into back then are the same issues that we will run into nowadays. They are very similar type problems that we have to solve with the trafficking of data in a distributed environment. that Erlang, back in the day, was able to offer a wide set of solutions, not only with the syntax, but also with the framework that it shipped with, called OTP. Now, I'm not going to get into the details of that framework, or even like I said, the syntax of Elixir, but I want to focus on how we think when we program in that environment, or on that paradigm, right? So after working with Elixir for a couple of years, I've come to the conclusion that in order to understand, especially the newcomers, in order to understand this paradigm, it's easier to focus on the 3 pillars, right? So these are the 3 things that I think make up for where Elixir and functional programming really have really shine, right? So the 3 things are pure functions, pattern matching, and recursion. So we're going to go over them a little bit and see how they all combine together and help us think of in terms of functional programs, right? So first of all, pure functions. Now, to understand pure functions, I'm going to steal an analogy by my good friend David. Some of you might know David. He's local to Orlando, one of the smartest dudes I know, and a phenomenal piano player. So if you next time you see David, ask him about his piano skills. It's just amazing. So I saw David do a talk maybe 4 years ago downstairs at the Iron Yard, and then he explained pure functions in the coolest way that I heard until then, and then I want to use this to kind of like explain the same analogy. So say I have a basket, right? But none of you can see the actual basket, right? And then I ask you, how many bananas do I have in this basket? But remember, you can't see the basket, so you have no context, right? So you can't really tell how many bananas there are in the basket. However, if you still can't see the basket, but I tell you, hey, I've placed 3 bananas on an empty basket. I eat 1 banana. How many bananas are left, right? Then you can easily get to the conclusion that there are 2 bananas left, right? Essentially, these are pure functions. That's how pure functions work. So pure functions, they follow 2 rules. Their return value should rely entirely on its arguments, and they have no side effects, right? So everything, all the information, all the data that's going to be processed by that function needs to be passed in as an argument to that function, right? And whenever that function executes, all the data that's changed, all the changes that are made to the world need to be returned by that function. No side effects must be made while running that function. Those 2 things alone, they give you a wide range of possibilities in terms of distributing your code to run in parallel on different nodes across the network. But we don't have to get into those details, right? Just remember these 2 things, and then next time you need to distribute your program in an environment like Elixir, you're going to find out that it's way easier than you thought, right? So let's look at some code. Let's look at what Elixir looks like. So this is an example of a pure function, of a module named account with a function called balance. Now this function takes 2 arguments, initial and spending, and returns the difference between them. So we run this code by referencing the module, calling the function, passing the argument, and then we get the return value back, right? Now, for those of you that have experience with object-oriented languages, let's compare that to kind of like the OO style of creating an object and then calling, a method on that object. Now the issue, one of the issues that you might run into the code here below is that you can't really just ship that object off to a remote node without knowing how that object was constructed. So behind the scenes, it's a little harder for you to scale this code without knowing, what the function is actually needing to return the account balance, and not knowing whether or not this method, current balance, is going to make any more changes to the world. So there's a possibility that calling that method might trigger some side effect. You never know. Whereas in the version above, you're giving that function again all the information that it needs in order to process, and then you're reading that value back. So that's kind of the difference. Up at the top, Elixir. Down at the bottom, whatever language that's object-oriented. It could be JavaScript, it could be Java, it could be PHP. So that's pure functions, right? Simple enough. Now let's look at pattern matching. Now, so pattern matching is one of those things that when you're learning Elixir, it takes a little while for you to get used to, but once you get used to it and then you start using it everywhere in Elixir, it makes it super hard to go back and program in any other language that does not support pattern matching. Because pattern matching is everywhere, and we'll see that in a second. Now, simple example of pattern matching, right? This simple code, right? If you've programmed in any other language, I don't care what it is, you've probably written code that's very similar to this. Now, in a lot of languages, we can just call this an assignment, right? However, in Elixir, this is a pattern matching. What's happening behind the scenes is that we have a primitive value on the right, the string Orlando, and then on the left, we have an empty variable. Now, the equal sign in Elixir is called a match operator. And what it will try to do is it will try to make the right-hand side match the left-hand side. In this example, because city is an empty variable, the way to make this statement true, or in other words, in order to make the right-hand side match the left-hand side, what it needs to do is assign the string Orlando to city. But that's not the goal of the match operator. It just so happens that in order for this statement to be true, the result is the assignment of the string on the right-hand side to the empty variable on the left-hand side, right? And I know this might sound a little redundant at first, but like try to keep that in the back of your head, because it will make sense once we start seeing this across the board in function declarations and return values, right? So here's another example of pattern matching. So here we have a list, right? On the right-hand side, we have a list with two string elements, Brooke and Sam. And on the left-hand side, we have an empty variable, users. Same thing is happening that it happened before, right? We have a value on the right, which here is a list, and then to the left-hand side of the match operator, we have an empty variable. So in order for Elixir or for the Erlang virtual machine to make this statement true, is going to assign the right-hand side to the empty variable on the left. Now, what if we now use the populated variable on the right-hand side, and then on the left-hand side, we use a list representation with two empty variables, right? Again, Elixir is going to try to make the right-hand side match the left-hand side. So because the right-hand side is a list, users is a list, on the left-hand side is going to find two empty variables part of a list. So what it will do is it's going to make the right-hand side match the left-hand side. So it's going to assign Brooke and Sam to the empty variables first and second, right? So this is an example of how you can extract elements from a list using pattern matching. So print that, prints Brooke and Sam. Cool. Now we're going to get into some more, I would say like typical list operations that you might have seen in other functional languages as well. So splitting a list into the first element and then the rest of the element. So what we typically call head and tail. So the code here is similar to the code that we had before, except now we're using the pipe operator. So instead of a comma here on the list on the left, we have the pipe operator. And what that's saying is slice that original list that we have on the right-hand side. Let's pick the first element and assign it to an empty variable head. then the remaining of the list, the remaining elements, assign it to a new list. We'll call it tail. Right? So head is going to be assigned Brook, the single string element, and then tail is going to be assigned the remaining of the list. It's going to create a new list composed of the remaining elements of the list. So Sem and Nikki. And if we were to go ahead and split Sem and Nikki again using the same technique, then the string Sem would be assigned to head, and then a new list with a single element would be assigned to tail, Nikki. And if we did that again, then Nikki would be assigned to the single element head, and then the empty list would be assigned to tail. What's up?
Can you use multiple, on the left side of the pipe, can you use multiple bindings? Like head 1, head 2, and then pipe tail?
I believe so. I believe so, yes. Yes, I think so. All right, cool. So let's move on to a little bit more of an advanced example of pure functions using pattern matching and also a new operator called a pipe operator. So here we have a module budget, right? A function called list transactions, and then inside of this function, we're reading a file called transactions.csv, right? File.read, module.function, pretty common. Transactions.csv, and what that's doing is it's using the return value and it's piping it to another function called parse file. So the pipe operator that we see down here, it's capturing the return value of the previous function and passing it as the first argument to the following function. So the return value of file.read is being piped as the first argument to the parse file function. This is a very common idiom in Elixir. We see this all the time, right? So parse file takes one argument. Now the return value from file.read, and this is a function from the built-in standard library. File is like a module from the standard library. And if you look at the documentations of the read function from this module, you'll see that it returns one of two things. If the file exists and if it was able to be read successfully, it's going to return a tuple. That's this data structure here with the curly braces, with the atom OK as the first element, and the contents of the file as the second argument. Or if for some reason it was not able to read the file, if the file doesn't exist, wrong permissions or something, it's going to return a tuple with an error atom and the specific error that prevented that file from being read, right? This still is one argument. The tuple is one thing that contains two elements. Either the first one is okay, and the contents, or the first one is error, and then the error message that prevented the file from being read, right? Now let's look at a potential candidate of implementation for the parse file function. This is a function that we're going to implement part of our budget module, right? So parse file is going to be a function split into two clauses, right? So these two versions of the function, they're called clauses. And they're not exactly the same function because if you notice, they expect different arguments. And what we're doing here on the method signature is exactly pattern matching, right? So when file.read returns OK, it's going to match the first clause. The OK on the first element is going to match the OK of the return value of the file.read, and it's going to find content, the empty variable, and it's going to assign the value of content to that variable. So we can use content from inside the function body. Now, if instead error is returned, then it's going to not match on the first one, and it's going to look for the next clause. And then it's going to find the parse file clause down at the bottom that matches with the error tuple, with the error atom inside the tuple, and it's going to assign the error message to the error variable so we can use it from inside the function. So notice that we didn't use an if statement. We're able to treat the different outcomes of the file.read function without using an if statement. And this is something that happens a lot when you use Elixir. A lot. You will rarely write an if statement when writing Elixir because you can do things like pattern matching and function clauses that makes your code easier to read.
Yeah. really cool. So that's what makes it declarative.
Yeah.
That's awesome.
It's pretty awesome. Yeah, and it's funny because when you actually write an if statement in Elixir, you take a step back and you're like, you question yourself. You're like, I'm doing something wrong.
This is wrong.
Yeah.
It seemed, again, I'm not very familiar with Elixir, but it seems like types as such take a little bit of a backseat.
Yeah.
So you're not going to get a warning at compile time if you don't have something that's going to match, like if you didn't implement a function that had the error atom, for example, it would just fail at runtime. Is that true?
Correct.
Okay.
With this, yes, there are things you can do to Elixir to actually check for types,
Yeah.
but it's not part of this code as is. Right? But you're correct.
Okay. Cool.
Now, moving on to a more advanced use of pattern matching, and it touches a little bit on your question, Matt. So this is, a simple example. This is a map, right? Key value pair. So name and age are keys. Brooke and 42 are values. So we're assigning a map to a variable person, right? Again, using pattern matching, right? Now here at the bottom, if we use the populated map on the right, and then we try to extract the values from the map, we're going to pattern match name and age, and because the variables name and age are empty, then Elixir is going to automatically assign those values to the variable. So again, we're using pattern match to read values from a map as opposed to map.get, map.fetch, or the bracket notation. We're again using pattern matching, right? So matches the keys on the right to the empty variables and populates them, right? And then a more advanced way of reading values is simply declaring the value that you want to read. So say, for example, all we care about is the name. We don't care about age, right? So we can just refer to the map, to the new map on the left as name, just forget about age, and then Elixir is going to pattern match only what it can, right? So it found name, it's going to populate name, and like just ignore the rest, it's not going to error out, right? It gets a little bit more advanced once we get to nested maps. So here we have a map where the key name and then the key address, and then the value of this key is another map. So if we want to read the state that's part of the nested map, we don't have to write the entire thing. All we have to do is write just enough code to tell it that there is a nested map. So all we need to tell is that there is an address key, that inside of the address key, there is a key of state, and then you can just let Elixir do the pattern matching and assign a value to state, right? And this, we do this a lot in Phoenix, which is kind of like the Rails of Elixir, is the web framework for Elixir. We do this a lot when we're reading parameter values at the controller level. We don't use a whole lot of methods to read the values from the params that the controller actions receive. We just use pattern matching straight up on the functions, and it makes the code look a lot cleaner than other typical MVC frameworks that you see. What's up?
You try to pattern match on a key that doesn't exist as a variable state. What is it?
I'm pretty sure it's going to error out. Yeah. On a key that doesn't exist, is going to error out. Right.
Can you, besides empty variables, can you fill maps? Like if I wanted name and state in a map, instead of two different variables that were...
Pretty sure you can, yes. Yeah. Yeah, so pattern matching gets really crazy. Like I'm barely scratching the surface here. Like once you start looking at it, it gets wild. And once you see it, that's not like, you cannot unsee it. Like you go back to like JavaScript or like any other language, you're like, man, I wish I had some pattern matching stuff to replace this like 10 lines of code that I'm writing here. So cool, so that's pattern matching for now. Talk about recursion. Funny thing about recursion, if you look it up on Wikipedia, you're going to come across a definition like this, right? They have a reference on the Wikipedia page for recursion that says, it mentions recursion as part of, the recipe for making sourdough. So the recipe for sourdough requires leftover sourdough from the last time that you made it. So it's like, right, so the canonical example of recursion. So recursion essentially is when a function calls itself from its body, right? So kind of like, the canonical simplest way to describe it. And what we typically see recursion as being an example is factorial, right? So in this example, if we call the factorial function, well, I have the example down here, sorry. If we call factorial 3, right, remember pattern matching is going to try to match the function clauses. So the first function clause has the parameter being 1. So if you call mymath.factorial 3, it's not going to match the first one. So it's going to look for the next clause of the function. It's going to match the one at the bottom. So once it matches the one at the bottom, it's going to use 3 as the variable n. So it's going to do 3 times factorial of 3 minus 1. So 3 minus 1 is 2. So it's going to call, again, factorial with 2. It's going to try to match with the first one. 2 is not 1, not a match. It's going to look for the second one. Again, it's going to replace it until 2 minus 1 is 1. Factorial 1 is called, then it's going to match the first one, and then return 1. And that's what we call the terminating scenario. So every recursion, every example of recursion has these two scenarios. The terminating scenario, when the recursion ends, and the recursive case, which is the function that keeps calling itself. So factorial 3 is going to return 6. Factorial 4 is going to return 24. This is the simplest version of factorial in Elixir. What's up?
So the matching is not because it's an order, but because one is more specific. Like n is free bound. Yeah, you go from
more specific to more generic, right? If you go otherwise, first of all, the compiler is actually going to help you out. If you try to compile an Elixir program, it's going to call you out saying, hey, you might want to reorder these functions because the function at the top is going to catch all, and the function at the bottom is never going to be reached, right? So, yeah, the order here absolutely matters. Yeah. All right, so this is like me trying to learn functional programming in college with like Lisp and Scheme, learning factorial. I'm like, all right, cool, factorial. Like, how do I use this on like a web app that a friend of mine wants to build, right? Like, there was like this huge gap between like what a website or a book is trying to teach me in academia and what the real world is actually requiring me to do. So I'm going to show you an example of like real world scenario where we can use recursion, pattern matching, and pure functions. So I'm going to use Orlando City as an example. Huge fan, haven't been in the game in a long time. So suppose that we want to build a simple program that reads from an API and lists the players of the Orlando City team, right? So here at the top would be an example. So suppose there is an API that provides us with like text format, JSON. We want to be able to fetch that API, build a list, and then return the list of players for the Orlando City team. What we also want to be able to do is read that same data and spit out just the goalie, right? So we want two things. We want to list out all the players from the team, and we also want to be able to list out only the goalie. Cool, let's see how we can do that. So we'll start off with the soccer team module and two functions, list all and get goalie. So the first one, as the name suggests, going to list all the players. The second, all the players, a list. And then the second one is going to just get the goalie. So we're going to call them like that. List all, get goalie. So let's look at the first one, list all. So here's one potential implementation. So here at the top, we're going to use a common library for HTTP called HTTpoison. So kind of like bear with me about the syntax. I'm not going to go over it, what it does and what use means. You can kind of like figure it out. So we have a URL, right? So this URL is the endpoint that returns the list of players, right? Then we use the get URL method. That's part of the HTTP library. We make that HTTP request to the API. We get back, JSON as string. Then we're going to pipe that to the parse function that we have at the bottom, right? Now, we're not going to go over all the edge cases. If the call goes wrong, if the server's down, if internet's down, let's just follow the happy path, right? So the happy path for calling this endpoint would be a 200 response back from the server with the response body, right? So that's exactly what we're going to match here at the bottom. So we're going to match with a map that has the key status code set to 200, and then whatever body comes with it, we're going to assign it to a variable called JSON response. Now, how many of you here have written code that does something like this, that fetches data from an API, reads data? All right, cool. So I just want to give you a couple seconds to try to picture what that code would look like in any other language that doesn't have pattern matching, right? You probably need to write at least 2 or 3 lines of code in order to check that the status was 200, to read from the body, to assign it to a variable, and then here we just do it straight on the function signature. So that's pretty dope.
Why the map here and not matching against 200 comma JSON response?
Because that's the format that the library that we're using, HTTP Poison, returns, right? So when we call the get URL, it returns a map. So we have to use that same representation, right? A map with a key, with 2 keys, right? Status and then body, right? In order to match.
Versus if it returned a tuple.
Correct.
Okay.
Correct. So yeah, like the difference is literally between a map and a tuple, like as far as representation, is the percent sign, right? Yeah. Yeah. So technically, this is a keyword lit. Well, let's not get into that.
I'm sorry.
Right. What's up?
What is the difference between def and def key?
I'm sorry.
What is the difference between def and def key?
Private. Yeah. So def, you can call like we are soccer-team.list all from the outside of the module, but if you try calling soccer-team.parse from the outside of the module, that would error out. So it's a private method. Right, cool. So we matched on the happy path, right? We matched on the 200 response. We assign the content of the response to the variable JSON response, which at this point is still a string, right? We want to convert that to an Elixir data structure. So we're going to use another library called Poison and call the function parse, giving it the JSON as string, and then what we get back is a tuple, right? And then again, we're following the happy path. A couple of things could go wrong here. We could read the data in a format that the library doesn't understand, but we're not taking that into consideration here. We're just following the happy path. And the happy path is a tuple with an OK atom as the first element, and then the data structure as the second element, which we assign to the empty variable list. And then finally, we return that variable from the function. So now when we call soccerteam.listAll, we can see the list of players that we got from our API, right? Cool, 1 out of 2. Now what we want to do is we want to find the goalkeeper and return the map, right? We're going to return a map with the name of the goalkeeper and then the position goalkeeper, right? So we want to be able to find one element from that list of elements. Cool. So this is the method that we're going to implement now, getGoalie, and we're going to call it soccerteam.getGoalie. Again, most of it looks similar to the list of players, looks exactly the same. We have the endpoint as a string, assign it to the URL variable, use the getURL function from the HTTP library, then pipe that to the parse function, which looks exactly like the parse function before, except that now we're going to pipe all the players that we have into another function called findGoalie. So findGoalie, remember the pipe operator. The pipe operator redirects the return value from the previous function as the first argument to the next function, which in this case is findGoalie. So let's look at what findGoalie looks like. FindGoalie looks like this, 3 clauses. On the first clause, it tries to match the first part of the list, which is the head, the first element of the list, to a map that contains the position equal to goalkeeper. If that sounds complicated to you, that's as complicated as it's going to get. Because that's it. Like we solved, like this is, you know, the terminating scenario. If this happens, we found our goalie. Like looking at this code and trying to understand, it will not get more complicated than the line that you just read. That's it. There's no if statements, no for loops, that's it. So once that match happens, all we care about is returning that head element. We don't care about the rest of the list. That's why we're using the underscore character here, because that can be whatever it wants. That's the Elixir way of explicitly ignoring something, is using underscore. We don't care about it. If the first element of the list that this function just received is a goalkeeper, that's it. That's all we want, right? However, if it's not, then that function won't be a match. And Elixir is going to try to look for the other clauses of that same function. So the next clause is, well, since the first element is not a goalkeeper, I don't care what it is. So it's, again, it's going to ignore the first element. What it cares about is the remaining of the list, right? Well, if the first element wasn't a goalkeeper, then the goalkeeper is probably part of the rest of the list. So I'm going to grab the rest of the list, assign it to tail, and call the function again. That's the recursive scenario. So assuming that the goalkeeper is part of the tail, we're going to keep going back between the first and second clauses until there's a match, right? We're assuming there is a match, because if there isn't, then the last time that the second clause is matched, then tail is going to be an empty list, because we're going to have gone through all the elements of the team and we won't have found a goalie. And for this particular scenario, I'm considering that an error. So I'm matching on the last clause and explicitly raising an error. So the last clause will only be matched if we ever give it an empty list, right? And like for those of you that know like the basic rules of soccer, like the team has to have a goalie, right? Even if the goalie receives a red card, they're gonna grab the worst player of the team and make him a goalie. Like there cannot be a soccer game without at least 2 goalies, right? So again, notice there's no for loop and then there's no while statement. We're able to write the simple, very realistic actually program using all the 3 pillars of functional programming: stateless functions, recursion, and pattern matching, which it gave us a program that's like, I think it's easier to understand, easier to test, and easier to distribute than its object-oriented or procedural counterpart, right? And again, remember, like once you get through that first clause barrier, like you look at the code, you're kind of like, wait, this is weird. I've never seen something like that. But once you start breaking it down, again, that's as complicated as it gets. Everything else is just a simpler clause, and it's just easier to understand, right? Now let's go back real quick to that first example, factorial. Now, like, if y'all understood the previous slide, this one should be like a breeze. Like, all right, I get this, right? So just 2 clauses, right? The terminating scenario and the recursive scenario. Now, there's an issue with this code. So this code works, right? It's not the best it could be, but it works. But here's an issue. If you call this code with a huge number, like 10 million, then something bad is going to happen, right? If we look at the activity monitor, so we're going to see that the beam, the virtual machine, is going to devour our memory. So 5 gigs of memory just for running that factorial, right? Now there's one thing we can do to make this code better and play well and leverage the Erlang virtual machine, which is implementing tail call optimization, right? Other languages, I believe, offer this optimization as well, which allows you basically to write recursive functions in a way that the compiler reutilizes entries to the stack. It doesn't have to keep adding entries to the stack every time it calls the functions again. Like once it realizes it's going to be calling that function over and over, it stops adding entries to the stack and just reutilizes that. So what that means is that it's going to consume a lot less memory. Now, the way to achieve that in Elixir is to make sure that the last expression on the recursive scenario is a call to the function itself. So remember, the last expression on the recursive scenario must be a call to itself. Now let's look back at that example. So what is the recursive scenario here? The first or the second clause? Cool. Now remember, for the tail call optimization, the last expression on the recursive scenario must be a call to the function itself. Now what is the last expression on the recursive scenario here? Exactly. So that's the issue. It's not factorial, it's n times factorial. So that small detail prevents the virtual machine from using tail call optimization. And that's why running this code with a huge number is going to cause that memory issue. Now, we can rewrite this code to use tail call optimization like this. Now notice the entry point, the public API to this module is still the factorial function. We're still giving it one argument. But then inside this function, we're calling a function that has an accumulator, right? So it's going to match that first call, and then it's going to go back between the first match, which won't be a match until the terminating scenario, and the second one. So the second version is the actual recursive scenario, but in this case, it is literally calling itself. That is the last expression of this function, is a call to the function itself, right? So we'll run this code again, and then we can see a huge difference, right? Less than a gig, like 24 minutes, right? So that's like the small detail that can make a difference in your program when you understand how to leverage, not only how to think functionally, but how to leverage the technology in question, which is, to some extent, is Elixir, but it's also Erlang, the virtual machine, that has been deployed for over 30 decades and battle tested, and it's pretty solid. So that was it for today. Covered quite a lot of stuff, and thank you. I don't know if there's any questions or. Questions?
Yeah, go on. Are you using this in production?
Yeah.
Yeah?
Yeah.
For web apps, it sounds like.
For web apps, using Phoenix, yes. So a couple of like big companies that have been using this to some extent. There's the messaging app WhatsApp.
Yeah.
So they they have been using Erlang. So they've been using Beam, the virtual machine, for quite a lot of time. And when you look at like the numbers and the resources that they use, it's ridiculous. It's like a handful of servers for like billions of people using it in the world. And there's various cases of people being able to drastically reduce the amount of machinery that they use to serve websites.
What type of other systems are typically coupled with it? Are there message queues or databases or NoSQL or?
Yeah, so CouchDB is one of them. Again, it's not Elixir. So Elixir is a rather recent language. It's only been around for less than a decade, like 8 years since its like beta release, right? But like everything that we say about like the underlying technology applies to Erlang. So Erlang was the language used for like CouchDB, and I think, is it called Ryak? R-I-A-K? Ryak.
Yeah, heard of them.
Yeah. So they use Erlang as well.
So I was just curious. I you know, new to the whole functional programming paradigm, what does architecture like kind of look like for like dependency injection, or like, you know, I just don't have a concept in my mind of like what architecture looks like in a functional paradigm.
That's a really good question. So specifically dependency injection, like I personally don't recall seeing it in Elixir. So the one like industry, the one community that like dependency injection is really like heavily used is Java, right? Like other than Java, like in C#, like Java-like languages, C#.net. Other than that, when you start like venturing into other paradigms, my guess is that a lot of the problems that dependency injection solve, like you don't run into them, right? So like dependency injection is a solution for problems that you like probably won't be finding in other paradigms.
So man, can you go back to your slide where you had like the okay, you're doing a pattern matching like the okay and the error.
Yes.
Yeah, I just make it break the computer.
Yeah, it seems like dependency injection is based on object-oriented thinking, right? You're injecting some more complicated thing.
Yeah, how do you kind of handle like, then even aside from dependency injection, like really inversion of control, like when you have business logic that you don't want to, be involved in the details, do you use like, I mean, I'm new to functional programming, but I know there's like a concept of like higher order functions.
Yeah.
Do you do that to like encapsulate
100%.
some of your dependencies so that?
Yes.
Okay.
Yeah, so that's exactly that. Like, dude, you hit it on the spot. Higher order functions help you a lot with that because you can literally just pass the business logic as a function, right, as an argument to another function, right? And then if you want to test that, you can just pass a mock version of that function, and then you can just like, you can separate your business logic from, the presentation portion, from the, data management portion. Like I would say that it's a lot easier to reach the separation of concerns using a functional language than it is using an object-oriented language. Mostly because of pure functions, right? You're not initializing an object and then calling a method that needs to look into the object for the properties, right? You're literally calling functions that they should have all the data they need as the argument, right? So
yeah.
So if you really want to go down the rabbit hole, look up higher kinded types, because this will give you what he's talking about, where you can kind of substitute that inversion of control thing, but it'll be type safe. Yeah, you'll come back to me in like 6 months, and you'll be like, why did you do this to me?
So one thing that really struck me about this is, from the outside, it kind of looks like the same way that the parse file would work. Great, stop me if I'm wrong here. But it works the same way with an object-oriented language, where I'm just doing parse file on some value. But inside, what's actually happening is instead of having like constructing an object that has the okay state and the error state and spitting out the result, I'm just matching I'm passing in that, and then pattern matching is just like taken care of.
yeah,
Whatever it is. Instead of needing to construct separate objects to get like polymorphism,
right.
pattern matching is actually going to do that.
Yeah, and coming from like Java, like at first this might be like, oh, this is method overloading, right? Well, except that like method overloading is with types only.
Yeah.
Right? You can define different versions of the same method. They take in different types, right? This is like taking a step further, right? You can actually do something similar. I haven't like shown the syntax or anything, but you can do something similar when you check for the type, right? It's called a guard clause in Elixir. But like, yeah, pattern matching is freaking dope.
So you mentioned that you use Elixir for making web apps, but beyond web apps, what kind of problems does Elixir make the most sense to solve?
That's a really good question. And then the answer to that problem is not the language necessarily, but the underlying technology, right? So the language is just like the very, top of the pyramid, so to speak. The language just happens to be nice, right? It just happens to be to almost read like Ruby, right? And that's intentional because the guy that created it came from years of Ruby, you know, a contributor to the Rails framework, to the Ruby language to some extent, and he was looking for a language that looked like Ruby, but didn't run into the same problems as far as concurrency, right? Ruby, kind of like Python, they run into a roadblock when it comes to concurrency, which is the GILP, the global interpreter lock, right? And it's part of the language. Like, it's been there since the beginning, and it's super hard, not to say impossible, to just remove that out of the equation and then all of a sudden make the language distributed, right? And then Joseph Aline, which is the creator of Elixir, he was looking around for solutions until he came across the Erlang virtual machine, which had all the items on his checklist for a language, for a platform that he was looking for, except Erlang is gross. Like, if you look at the language, it is extremely hard to digest, right? So what he did, he basically created a language, another language, Elixir, that looks like Ruby, which is super easy to understand, but compiles to the Erlang bytecode, right? So now going back to answering your question, what kind of problems does it solve? Like, the platform itself, Erlang, the virtual machine, it offers a set of built-in tools for writing concurrent and distributed code, right? Which, because the nature of the language itself, both Elixir and Erlang, they rely heavily on these three pillars: pure functions, pattern matching, and recursion. It's very easy for a language implementer, for like the virtual machine, to read code like this and make it distributed, right? So as I was mentioning, you know, like, it's more efficient, it's more memory efficient, and you can handle a lot more load with a lot less machinery when you do something like that. So anything that's like network heavy, when you're getting like a bunch of like requests and you need to process that and spin it off to multiple servers, asynchronous calls, all of that stuff, Erlang is, you know, a great platform for writing code like that.
So kind of in line with that, what does async programming look like in Elixir?
That's a really good question. It's not part of the talk, but like I can like browse and show some of that code.
Yeah, because I mean, just being familiar with, you know, JavaScript going into Go, kind of has Go routines, which is very different to Java, which is, you know, kind of hard to get that reactive.
Yep.
You know, it's not very natural in the language. So I was just curious what it looked like.
So Elixir has this thing called Gen Server. So that's essentially, so again, because of the set of tools that are shipped with the virtual machine, like the Erlang virtual machine, it's called OTP, Online Telecommunications Platform, which was initially developed for telephone lines. You know, computer networks are very similar, so it just happens to work. So they have this module, part of OTP, called generic server, right? So that's how asynchronous communications, so that's how you can write asynchronous code in Elixir. One way you can write asynchronous code in Elixir and Erlang is using a generic server, right? Which the implementation of the server is a bunch of callbacks, right? And then once you have a client, so you don't have your client communicating directly with that code, right? You have a client communicating with the virtual machine, and then the virtual machine is making all those callback calls, right, on your behalf, right? So in the same way that when you write a callback in Node.js, you're not, like, your code is not calling the callback, you're giving it to V8 to call it, right? So this is kind of like the same thing in Elixir, but you don't use callbacks, like, you know, function callbacks the JavaScript way, right? You write kind of like a, you know, I think delegator in iOS, you just like state the functions as part of your module, and then you mix in the gen server module, and then you let the virtual machine call those methods for you. So that's like essentially like that's how asynchronous code works in Elixir, right? In Erlang. So, and somewhere here, I don't think it's here, but like when we look at more advanced, right, process ID. So this right here, process ID. So this process is not operating system process, not OS process. It's a concept of process that's specific to Erlang. And a process is a lightweight concept. It's not as heavyweight as a process is in an operating system. And a process can live across the network, right? So calling gen server call PID, this process can be either part, like you don't know, this part is transparent to this code, whether this process is in the computer that's calling it, or if it's in another computer in the network, or if it's on the other side of the world, right? So that's what's cool about the virtual machine, is that it makes like all this code like just magically work once you adhere to the style of programming, right? So again, pure functions, you know, recursion, pattern matching, like if you follow like the recipe, then once you want to distribute your servers, you kind of like just turn on, you know, different servers, you just like connect the nodes between themselves, and the distribution is taken care of by the virtual machine. And this is like an advanced topic for me. Like I personally have not worked heavily with this, but like I know that this is like the entry point for, you know, distributed code.
No, go for it.
Do you know any good GitHub repos you can look at?
Like not off the top of my head, but like you know, Phoenix, which is the framework itself for like the web framework, is a good one. I know there's like a, you know, the awesome something pattern that like a lot of people use on GitHub, like awesome, you know, Elixir, awesome, you know, Ruby, and then if you just look for like awesome Elixir, I'm pretty sure there's like a GitHub repo with a bunch of open source. Or you can also go to GitHub and go to like popular repos and just filter by language, and Elixir is there, and then you can just like browse. That's a great question. That's the best way to learn like a new language or framework, is to just browse through the source code. So yeah, really good question. So.
Okay, so this is super badass. Now I'm excited again. I talked
Awesome.
to you earlier about that. So for external libraries,
yeah,
like the support and stuff like that, because I'm dealing with external things that are not written in Elixir or on the Erlang VM. But I'm dealing with Java and the JVM, stuff like that. But you know, sockets will work just fine.
Right.
Like that. So what kind of libraries that do have side effects and so on, like the external stuff? What kind of support does Elixir have for that?
So there's like a, you know, the ecosystem, you know, Hex package manager. You can add external libraries, but what's cool about that is another feature of, again, not the language but the platform. Once you start reading about it, you're going to see this a lot. It's called fault tolerant, right? And they follow a concept of the let it crash, right? And what that means essentially is that, remember the process I told you? There's like hundreds and thousands and millions of them. And you know, when you run Elixir applications, and a few of these processes are called supervisors. And the goal of the supervisor process is to monitor children processes. And if they die, there's a bunch of different ways that it can treat that specific situation, right? So even when you're using an external library, when you add it to an Elixir project, it's going to be part of the supervisor tree, right? So when you're on one particular scenario or one particular area of your application, your entire application is not going to crash, right? Only that particular case, and then the supervisor will then take care of it, right? And then there's default behaviors for supervisors, but you can also write your own supervisors depending on, you know, your needs for your application, right? So some of them you want to start right away. Some of them you might want to do some cleanup before starting. Some of them you might just want to let it die and not resuscitate again. So there's 3 or 4 default behaviors, and then you can also like write your custom ones. So that's kind of like how it works with external dependencies. So everything is a process and everything is managed, and that's why like you're gonna see like the let it crash and the fault tolerant aspect of Elixir, because like it's part of the language to try and make each part not affect the whole.
What about data durability? So I got like 5 of these processes running, and 4 of them are okay, and I get a bad piece of data. It comes in, it crashes on it, but I don't necessarily want to lose the data that I read there. Maybe I not necessarily want to give it to somebody else because they'll probably crash.
Right.
But what happens in that case? Where you kind
Again, it depends. So each process, you can also code what it needs to do when it crashes, right? So if I remember correctly, like you can implement some kind of flush, right? So even when it crashes, there's like a function that's going to call before it actually crashes. So there's different things you can do about keeping that data around. And there's also it's called ETS tables, which is again, it's part of the virtual machine, it's part of OTP, it's part of Erlang, which is kind of like a built-in type Redis. So it's part of the language. So it's pretty powerful. Once you start reading about it, you're like, holy shit! Like 30 years ago, people were solving problems like this. So yeah.
Nice. Thank you.
Yeah.
So the functional language that I'm most familiar with is Haskell. In Haskell, you literally can't have side effects. Like the language prevents it. And I know that just from reading it, that's not what's happening here. But is there an opt-in where you can say like, so essentially with Haskell, if it's not marked with a certain type, it's impossible to have a side effect. So now as a consumer of a function, not only do I just kind of hope that the person who wrote the function was following these rules of not having side effects and all these things, but I'm guaranteed it by the language. Do you know if there's any sort of opt-in guarantees like that for Elixir?
I don't know.
Okay.
I don't know.
Yeah.
My first guess would be that the language is not as strict about that as other languages like Haskell.
Yeah.
But I don't know.
Okay. Any last questions? All right. Round of applause.
All right, everybody. That will pretty much do it for this evening. If you don't mind helping me set up the room before we all get out of here, I would very much appreciate that. I also would not be doing my job because we at RESTful are actually hiring, and I forgot to mention that at the start. So if you are interested in doing software development at RESTful, please come talk to me. Maybe we can see if it might be a fit. Still looking for speakers, so if you are inspired to give a talk based on something you saw tonight or something you're heard about, please come find me. And I think that's it. Any other announcements?